Hi everyone, thank you for joining us today. Let's start. And today we are going to tell you about the design system we are working on together with the developers. And let me first introduce my fellow designers and myself. I am Alexey, and I'll tell you how it all began and how we came to create our design system. It will be some kind of retrospective. Ekaterina will follow me. She has reworked the design files on a product, and now she is the main custodian of the design artifacts and monitors the consistency of design solutions. And Ekaterina will tell you how we improve design files in Figma. And Daria, she will tell you how we improve interaction between design and development teams. She really helps us to speak the same language. So our presentation will consist of 3 parts, and let's start from my part. As you probably know, a lot of words have already been said about the design system. But before I get down to history, let's first understand in a few words what the design system basically is, what it consists of, and try to understand why it is needed. Actually, design system typically includes the following things: branding guidelines. This includes a logo, typography, color palette, and any other visual elements that represent the brand. UI components, they are the building blocks of an application. This includes buttons, forms, navigation, and other interface elements that users interact with. A design system should provide a library of these components that can be reused across the application. And next point is the design patterns. They are common solutions to recurring design problems. They provide a consistent way to solving problems and ensure that the user experience is consistent throughout the application. And also, design systems should include guidelines for developers, including coding standards, documentation, and best practices. This helps ensure that the code is consistent and maintainable. And of course, the accessibility guidelines. As you know, accessibility is an important side of any applications. And therefore, a design system should provide guidelines for creating accessible design and can be used by people with disabilities. So we can say that design system is a collection of reusable components, guidelines, and standards used to build and design digital products. It helps maintain consistency and efficiency in the design process, enabling designers and developers to work together seamlessly. The products using the design system are united into a single whole that forms a kind of an ecosystem with a single core. Well, we figured it out, and now I'd like to focus more on technical issues specific to our company. And let me give you some background and tell you what we had approximately 5 years ago and how we deal with it. So at that time, the file structures, tools, and processes weren't very convenient, were too complicated, and delayed the process of transferring design specification to development. And here are the problems we had. Our company, DevExperts, have DXtrade platform that actually was our flagship. And this is a stack of its design files. And we had a large number of related projects that we sometimes call white labels. And this is just a small number of white labels that we had at that time. Also, our projects are developed for several platforms. I mean, each application is usually developed for a web and mobile platforms, but some projects are developed for a full set of platforms. For instance, Phenom, it has a desktop and a web application, an iPad application, mobile, Android, iOS, and Apple Watch. And almost every one of our projects has 2 color themes, dark and light. And as you can imagine, it was difficult for us to cope with all these files because we didn't have a single library of components that actually didn't let us work quickly. As you obviously know, designers are currently working at Figma, but 5 years ago, we worked at Sketch application. It was the post-Photoshop time for the interface designers, and Sketch was the most advanced application for designers at that time. Figma appeared a little later than Sketch, but to be honest, at that time, Figma was very raw and inconvenient. As you could see, there were many projects, and since we didn't have a single library of components, we had no and only source of truth. What sometimes led to a design discrepancy. It cost us a lot of effort to maintain the consistency of design solutions across the projects. And also, there was no possibility of working with design files simultaneously. Sketch had no multiplayer mode, and that was a problem. We had to go for some tricks. We used some kind of GitHub technology. Sketch files were uploaded to Stash, and that is our local file storage, and back to Sketch using source tree application. We wanted it to work the same way as it works for developers, but actually it wasn't the case. Sketch file isn't the code, so this approach didn't work out the way we wanted it to. This means that only one designer was able to work with a particular file at the particular time. Therefore, the designers had to notify each other that some file was busy, and other designer had to wait until the file was committed to the repository, download the updated file, and only then start working with it. All this took a lot of time and slowed down the work. And our next pain was the transfer of design specifications to development. Unfortunately, Sketch only existed for Mac OS. As far as I know, there is no Windows version yet. But we had to pass the specifications somehow to developers who worked on Windows. To do this, we used the online service called Zeppelin, where everyone who had the link had an access. Designers uploaded specifications to Zeppelin, and here is an example of one of them. In addition to transferring design specifications, Zeppelin performed another important function for us. This is a transfer of color tokens to developers. But this transfer was unreliable and could only be done in a semi-manual mode. Token names were indicated as simple comments about the text, background, lines, and developers took the names of tokens and transferred them to the code by hand. And only the token names were passed through Zeppelin. And for the transferring token values, we use our wonderful Chameleon. Chameleon is our internal product, which is a storage of color tokens and their values. And it was one of the first steps towards automation of the work with the design systems. And it is still the link between the design and code. We have some plans to extend its capabilities and store in Chameleon not only color tokens, but also any other types of tokens. So time went on, and Figma had not only caught up with its rival, Sketch, but had also surpassed it in many ways. And the killer features were that Figma was a web application for working with any number of users and the same time in a single file, and only computer with just a browser and the internet. No matter Mac OS or Windows, So it seemed fantastic, and we decided to move to Figma. And since then, a lot of Figma plugins have appeared that have significantly expanded its capabilities. Thanks to this Figma API and our developers, we have now an amazing plugin called Chameleon 2. This plugin can export and import tokens and their values to our Chameleon storage and back to Figma and detect the duplicates and merge them. Actually, this plugin greatly simplifies our life, really. Now let's talk a little about the design specifications and how we improve them. So, as I said, we jumped off the sketch. All design specifications of active projects were moved to Figma, and we realized that it was the time to collect into one master file everything needed to maintain current projects and design new ones. Of course, we started with our flagship DXtrade. That master file included a complete UI kit, the main list of widgets of our projects by platforms, OTC, brokerage, crypto, and other important things. Finally, designers have got a single source of truth. It could be possible to find the design of necessary widgets, controls, and color tokens for DXtrade related projects in that file. So the first stone was laid in the foundation of the future design system. The products that appeared at that time were built on the basis of this master file. And concluding my part, I'll tell you about the product that we call the Web Broker Order Management System. Initially, Web Broker was developed as a separate product. It had its own component library, styles, and tokens, but then it was integrated in DXtrade, which started serving as a wrapper for the Web Broker widgets. And as a result, we got two different UI kits in one product. Of course, it wasn't convenient for us, and we decided to merge two libraries into one. And these changes affect not only Web Broker, but also DXtrade. And during this time, we also made a lot of big and small improvements inside Figma files that helps us a lot. Now, Ekaterina will tell you about these improvements. So let me give the floor to her. Kate, a microphone is yours. Please go ahead, and thank you for your attention.
So let's go. Today, I'd like to tell you about design system of our Web Broker project. I joined it from almost very beginning, and here we are, some current results of work, and I'll show how it was born, developed, and transformed too. This is how Web Broker looked like in Figma when I had just started my work on it. Process was organized by dividing our layouts into dev, concept, and release sections. As a new designer, I had difficulties how to understand and to remember when should I move spec from one section to another, what role spec status plays for me, and whose draft in the concept section has been laying around for 3 months. Here you can see big letters describing rec number. So if you were trying to find something by common sense, you should have a large amount of patience. It was not obvious at all. This happened because we started to design Web Broker based on tickets and recs, but not logic, rules, or structure. So how did we design at that time? If designer worried about consistency, it took time. For example, your task is to design simple model window, and you want to know what size of spacer in the footer. So be ready to watch every spec to find out the answer. Maybe 24 pixels or maybe it's 28 pixels, nobody knows. Then you maybe go to Slack and try to get the answer from your colleagues, and maybe somebody knows what decision is correct. Sure, if your priority is speed, you just create a new space type. So let's give your future colleagues opportunity to think, to spend more time, to make some research. It's sarcasm. Of course, we had something could be called as design system at that moment, but we share it with another project. So to make any edits, it was a problem because you have to go to your colleagues and approve a lot of things. And the easiest way was just not to touch anything. So follow up. Design based on specification, not logical structure, is a book without content list. New designer met a zoo of components and had to spend a lot of time looking for correct answers on simple questions. And shared design system was very inflexible without any development. And of course, we wanted to work with pleasure and with saving our nerve cells. So we headed to design system. You know, I remember that moment that I put a piece of UI kit into order and got a static pleasure because chaos started step by step to transform into design system. Very good feeling. And today it's been more than a year since that time, and our design system had a lot of changes. And I'd like to introduce to you our result that we're proud of. Ta-da! Maybe it looks like something big and something complicated, and it really is. But don't worry, I'll be your guide. I'll explain most interesting things. We have three, I called it wheels of design system it's based on. Nobody got that image in the head, but we created with logic, common sense, and empathy. And finally, we found out that we have a few principles, rules describing the result, 3 principles. First of all, it's a logic-centered structure, not specification-centered. We reworked our past specification and make some documentation in Figma, components, behavior, and rules. The second, that all should be on the cursor or on the hand, which means that we have hints, notes, something that help to figure out something faster. And our design system is alive and self-improving. What does it mean? When you're watching things laying in the good structure like skeleton, it becomes clear to see what part is a white space and need to be filled. So in our design system, we divided all stuff into visual components and their behavior describing. Thus, we kept the balance. From one side, we have a neat components library, and from the other side, we can see how it behaves, how to use this component. This is how our design page now looks like. Here you are behavior part. This is specification we report, and components part. All components are arranged into baskets or boxes, whatever you like. For example, teammates could easily understand how any drop down look like and how it behaves. Look like here, behaves here. Few words about these subblocks. In subblock elements, we kept atomic things like buttons or inputs, and the fact that is our design system based on atomic approach, where complicated elements assembled from elementary, like bricks. For instance, all teammates could see how diversity of buttons looks like. So for designer, there is no need to draw it again and again in new spec, and that's a profit. So atoms are here and molecules in the next frame called content. approach of forming complex elements like tables, models, etc. allows designer to start work with it immediately, instead of searching all over the file how to build it properly. So Figma allows to adjust these components to the task. Designer can change states of the components without changing components itself. Here we are, for example, the panel with buttons, and we can change button state, like hover it, focus it, but this is still the same component. Thanks Figma for this feature, and thanks for us for using it. You need to design few more screens with different buttons. Easy. With our design system, it takes maybe 2 minutes. Design system is not only a visible part of design, this is also service elements that help us to maintain consistency. Here we are, the service block. Variables have their hierarchy. It's easy to find and to understand what it belongs to. And describing the text styles helps designer to find font size or font family easy. You see hints. Pay attention. This is the second wheel that all should be under the cursor. These hints help us to find quick answers for simple questions. Then link system here helps everybody who work here. For example, designer has a model window in the spec, and it should be mentioned somewhere where this model is located. Earlier, we used to draw the same thing again and again in every spec. And now we just can paste a link to a common model window spec, and that's all. Only one little link. Spacers help us to maintain their consistency and not to create the diversity of different spaces, like 28 pixels, 24 pixels, remember, as I mentioned before. And specification headers that we use in well-designed system consist of necessary information. For example, developer can easily find who is the designer, and date. Date helps to understand how old or new or even legacy is our spec. And rec link number helps to realize for developers, is this what they need? So maybe not. And due to color selection, you can just have a fast look. It's enough to find out the status of the specification. So service components help our team to maintain our design system. And I'd like to introduce to you the huge behavior part. This is a documentation worked out and transformed from a formal spec with some edits and addings. Here we are, logic blocks and common skeleton of design system. When we build the design system based on logical structure, it's easy to see what should be added. I'll show you. For example, we have big issues with table action specification. And for one button, there is a tooltip described, you see. So the question arises, what for the rest of the buttons? Do they have a tooltip? What rules for the tip do we have? And all of this question leads us to create new rules for these buttons and view it to actual system. Thus, we realized the third wheel of design system. It's alive and self-improving. Little lamp story from my life. It's not enough to create documentation and components. We have to maintain it. And I'd like to say, for this purpose, every detail is significant. So, my story. Once I decided to buy me a gift, to buy myself a gift. I took an amount of money, went to the shop to buy a ring. And I was looking for one ring, was just curious, and I saw one cat is blinking for me. this. Imagine 13 cats with closed eyes, and there is only one cat who was blinking. It was such a surprise to see it, to find this detail. So I bought this ring, and I never regret about it. But the interesting fact is that jewelry cost 3 times more that I was going to spend. And now this ring, yes, on me, this ring reminds me every day how important details are. So we pay a big attention to details in our design system too. Let me tell you how it works and how details help our team. Just imagine you are a new designer, started work on project. So you have to find a start point to answer a lot of small questions like, do we have to change a cursor from pointing hand in this place, etc. And you are trying to understand how widget works, what is functionality, what your colleagues have already done with this widget, or another flow. You're a developer, you've just opened a ticket and designer's frame, and you want to understand, is it a correct frame? Whom you may go to ask your questions, and why sizes of components hasn't been described again, because on last grooming we've talked about it again. And one more flow example. You are a viewer or custodian of design system, and you are trying to maintain the consistency. But your teammates often make their own decision that looks so different from each other. Good decisions, but so different from each other. And how our design system can help all of us. This is how design page looks like. Pay attention. Instead of popular dev concept release approach, we use system of branches. This is new Figma feature, allows us to avoid chaos because everybody draws something here. And it helps every teammate who is looking for actual spec. However, concept section is still here. We use it as a place for designer, where is a place where designer can create something, but in a branch, or as a board for some hints. Widgets are arranged into basket boxes. That means that specification belong to one widget are in one place, in just one box. And it allows for any new teammates who had just met a new widget to define what the functionality of widget and what has already been done here. No need to look at all over the file. Inside widget boxes, that's inside widget boxes, we have a widget guide frame. For example, we described it there, context menus, list items, and we added a few links for more information. And it allows a new teammate to learn more about widget functionality. And for design system custodian, it allows to find some white spaces to be described. For example, if we see describing only 3 menu items from 5 item menu, that means that it should be described 2 more items. And I've told we use branch system to maintain the consistency. So designer opens a new branch for work, and after the custodian checks the work, he or she approved the merge. So in the concept section, we have now 3 frames. Empty frame is started at the entry point. So just copy and start work. Widget guide frame, as I've mentioned before, and started kit with some interesting things the designer may use. For example, popular links like here, onboarding features, hints, etc. And also in started kit, we have useful checklist. It reminds designer to take into consideration all corner cases and details like minimal or maximal size of components, validation, overflow cases, etc. It helps to well designing process because designer comes to grooming with developers being prepared to any questions. And finally, developer comes to designer with maybe 2 questions instead of 10 or 100,000. As a matter of fact, this checklist was born after hard grooming of my specification. So since the time, our design team asked themselves before grooming, but not during grooming. And also, to make developers' life happier, we created these headers, I've mentioned it before, with necessary information. So remember, here you are, rec number, status, name of designer, and all for you, our best developers ever. And final details. I like when everything is arranged into boxes. I've mentioned this word many times, boxes. I like when it's easy to navigate through the file. And all our Figma guests, we provided helpful things. For example, designer can draw a rectangle into 2 ways. Here you can see the first way to do it. We use frame here because it hides titles of this frame. Thus, we avoid visual noise and help people to navigate, and only necessary things like this are visible. On the other side, this is the second way. We use shape here, no titles, you see, but titles of the frame inside are not hidden, they're visible. So it's very convenient when you zoom in out and you can see content located here. So my speech comes to an end, but before I finish, I'd like to tell you one little funny fact. Imagine you are doing your job and you notice some small moment that has to be edited, or maybe you call a ask to edit something, and it's not very complicated, not something very complicated, but it's a routine that draws you away from your task. And we met the same problem. So finally, we decided to use these sticky notes in Figma. And later we decided to add their name, task status, priority, and finally we realized that we invented Kanban. Now we always have black clock for design system task. So design system is alive and self-improving, remember. Sure, it's not the end of our design system journey. We have future goals and dreams. And one of the dream design system for a larger project starts to come true. My teammate Daria will tell you about it more detailed. So thank you for attention and meet Daria.
Thank you, Katya. You've done such a great job. And after diving into details of design system files, I'd like to talk about our next steps in its development that we're working on right now. It is not a big secret that communication between design and dev teams sometimes might be naughty. To develop an ecosystem Katya is dreaming about, we had to start with solving this problem first. Let's answer the question many people may have wondered. Is the mindset of developers is so different, and is it actually possible to keep people communication process in sync? Let's start with discussing components view. This is, for example, how button component looked in our design file. One frame contained all its themes, states, and types. These button children, we call it instances, are used all over the project with overridden text fields, of course. As for the development, the same visual component will be presented as a reusable block of code that can be applied anywhere in project. So in fact, it turns out that the behavior and logic of interaction with the component are completely the same. The difference can be only seen in its presentation, visual in design and code block in front end. The list of UI components was different for a long time that led to a conflict and was really slowing down our process. We ran into a problem when our design system in the code was the completely different entity than the designers intended it to be. The set of components, their structure, naming, and sometimes even the logic of behavior were different. There's no usage from the design system until the principles of its scaling are not agreed with the developers. Our developers, by the way, use Storybook for isolated testing of UI components. And if we look closer at the left sidebar, we can see a clear tree structure. Over time, it became obvious that for a complete mutual understanding, this structure must be identical. After several months of regular interactions with the developers, component by component, our design systems finally became twins. Imagine the designer came to a developer and asked him to fix border radius in some model window. Well, surprisingly or not, lots of components in our design system had different names. The same element might have different name in the code. Understanding only can be found throughout the persistent dialogue. Let's summarize everything that's needed to be synchronized. First of all, it's a scaling rule. No scaling, no future. Common naming approach. If we speak the same language, let's do it in the same terms. Logic structure. Without it, scaling is impossible. And obviously, good design dev communication process. I think this one is pretty much self-explanatory. Moving to the next step, scaling rule. To ensure scaling, we had to find an understanding of when elements should become a part of our UI kit system. That's why we have developed a certain rule. This is a set of binary questions, the answer to which will lead you to the final decision. And the first auxiliary question, is element reused or planned to be reused in different contexts? Imagine we are talking about some switcher components. It could be used as a theme change control and also as an enabling practice mode functionality, for example. Regardless of the answer, let's ask ourselves one more question. Is the element similar in functionality among existing components? If not, then this is not a part of UI kit component. An exception would be a situation when we already understand that element could be reused in near future. I mean, theme switcher is being discussed, but practice mode functionality is already on its way, so it's going to be implemented in near future. So we need to understand that. Well, if the answer is positive, then that element has the same style as an existing one. If yes, then this is a new type for already existing UI kit component. If not, congrats, we just found a new component that should be added in our UI kit. Well, seems like scaling principle is figured out. Of course, not to mention all these agreements must be supported and decided by both teams. Next on the menu is our abstract naming. Well, abstractness is important in the code. There will be no problems with the expanded calendar components when the client suddenly wants to change color palette. We all know that happens sometimes. Such a calendar does not require many resources to use in another place or project. Its name is abstract and describes only what is it and how it is behaved. But the component name gray order entry calendar binds not only to the application context, but also to visual style. So the name of all components from icons to more complex and compound elements should be revised. Don't forget, of course, about variables. We use design tokens to describe visual style. For example, instrument info panel writes spacer S, declare writes padding in info panel, which meanwhile is placed in instrument. Those token names are also must follow some strict rules. Once upon a time, developers shared us the benefits of BEM approach, and then it became clear that we could use the similar system to our design token names. Let's see how it works. The token consists of 3 parts: block, element, and modifier. The first two answer simple questions such as what is it? The block could be folded and nested in each other. Instrument, for example, here is a block and describes the first outer layer of the variable. Elements also can be nested and even have any numbers of nesting levels. For example, info panel has 2 levels. And modifier usually responsible for visual appearance, what size of an element, which state, what font size, font family, I don't know, border radius, and etc. Our designers also have some naming convention that describes specific rules in creating color token names. Token is divided into several parts, and each part has semantic description. All these agreements stored on Confluence, and every token matches chosen semantic. So we use like mix of these approaches. Thus, we got a list of tokens with easily to read and intuitive names. Let's sum up our results. Scaling principles are established. We have one precise rule that describes logic of adding new component, and both developer and design team can understand and use this rule for developing design system. Naming approach also allows us to create homogeneous token lists. Design system structure in Figma matches developer performance until, although we're still working on it, but the progress is obvious. And last but not least, in the process of negotiation, well-established communication with both teams was finally achieved. Let's move to tokenization process. First of all, design system tokens are the style values of UI elements such as color, typography, spacing, shadows, whatever. Almost everything in our system can be described by design tokens. They are like building blocks of the design system. Think of them as sub-atoms, the smallest pieces of style values that allow designers to create styles for any product. For example, this button is described by primary button default BG token that has specific value, and it describes its background color. Imagine we have another project that uses the same button component, but color token value is different because of project style. They like use blue instead of yellow. Such a system can be scaled to unlimited number of projects. For some of you, such magic can be already familiar, but what will happen with the dimensional tokens? Because it's like more complicated than color tokens. Let's say first project border radius is 0 rem. The same way, border radius will be redefined to 4 pixels for this. 4 pixels for the second project, and 2 rem for the third one. Continuing this logic chain, we get a style creation system ready for scaling and restyling. And this is button anatomy. All visual elements are described by tokens and its values. Our project designer will be able to override these values per project. For example, first designer set border radius as 0 rem as well. As second one changed default value to 0.2 rem. And the third one need more smooth buttons, so he chose 1.2 rem. For development team, it means that all this restyling process goes without their interaction, and they can focus on more complicated tasks. What is the final goal and advantages of such system? This is how architecture works right now. We had some big parent projects. This project has its own UI kit, its own components library. And on its components, we decided to develop our global UI kit. After months of hard work and its systematization, the component library has become an independent entity and is ready to be separated. This library, we call it DixKit, has its own repository with the version control system. Imagine some projects is going to be connected and it wants all current updates. So the latest version goes here. But some projects like the second one here could be okay with versions because they simply don't need the latest updates. So as a result, connected projects use components they need. But what if some projects need unusual inputs that does not exist in design system yet? In this case, they can make a request to our design system team, and then they will make a decision if this input could be potentially used in other projects. And if so, they will develop, test, and add it to new DXKit version. Otherwise, project developers should do it themselves, just because this component they requested is too unusual and unique and can be specified only in this specific project. So all these projects are called connected to design system, and even the parent project we started with will make use of design system as well. And does it mean that all dev experts projects will be connected to a new design system? In fact, not at all. This is a personal decision for each project to realize how effective and beneficial such a connection will be for them. However, all new white labels projects will be based on DXKit, because it's will be easier for developers first of all and for designers as well. One of the most important questions, will the workflow change? The short answer is yes. And to find a more detailed response, let's refresh our memory with the situation we started with. Design has not just changed border radius in Figma for the same component as he used to do before, but also updated token values. It basically means that developers can already see changes in the platform and they don't need to write a single line of code. So why this system should make it easier for our teams? First of all of them get access to tested and accessible components. Like they were checked and tested so many times that you do not have to worry about accessibility requirements and etc. There's also no need to worry and endlessly improve the design system. Focus on development, more complex elements, please. Developer teams no longer have to deal with the redesign issues. And last feature, access to full and detailed design and code documentation. This is actually all I wanted to say about our lovely design system of the future. Feel free to ask any questions.